Functions of the heart. One of the prime functions of blood is to carry oxygen to the cells of the body to be used in the energy production and the removal of waste from the cells, including carbon dioxide and heat. Right? Now, as blood is a fluid, and we know that all fluids flow from a high to a low pressure, as we have seen previously, the purpose of the heart then is to create this high and low pressure areas relative to different parts of the body, to assist in the flow of the blood to the body cells and its return back to the heart. So when we're talking about the functioning ability of the heart, what we're actually referring to is cardiac output, potential of the heart. So cardiac output is the volume of blood pumped by the heart per unit of time. And remember, per unit of time is normally always 1 minute. So the cardiac output is expressed as an equation saying cardiac output equals our stroke volume times our heart rate. Now, if you look at the flow chart, you can see the big heading, cardiac output. So cardiac output is the product of stroke volume times heart rate. So for us to understand training and understand the implications of our training and what it's doing, then we need to understand all the factors that affect stroke volume, and we need to understand the factors that affect heart rate. So if you follow that flow chart, stroke volume is affected dramatically by, we go right to the bottom where it says increased venous or arterial pressure. So if I increase venous pressure, what I'm actually doing is I'm increasing the volume of blood that is flowing back towards the heart. And remember, venous blood flows back predominantly by contraction of the muscles. The muscles contract, squash the veins, and then that creates a high pressure system and forces the blood back towards the heart. The blood can't flow backwards in veins because the veins contain all valves that prevent the blood from flowing backwards. So it's just a one-way process. So if we increase the venous return coming back to the heart, we create what we call a preload. So an increase in preload is the increase in volume of blood coming back to the heart. So what does that do? If I increase the volume of blood coming back to the heart, I increase what I call the end diastolic volume in the heart. Okay? So this comes back to what we call, and we'll talk about it in the next small section, is related to Frank Starling's law. Because if I increase the preload, if I increase the volume of blood coming back to the heart, then the more blood I push into the heart, the more that stretches the heart. Remember, muscle is an elastic tissue. So if I increase the volume, I stretch that muscle. The more I stretch it, when I let go, the more forceful that muscle will contract. And therefore the heart will contract more forcefully and pump out more blood. So what it does then, it increases the amount of blood that actually goes from the atrium into the ventricle. So I increase my end diastolic volume. What does end diastolic volume mean? Remember, I have two types of movement within the heart. I have a systolic and a diastolic, right? So this is what's called my end diastolic volume. So in other words, the volume of blood that is left there after the atrium has contracted and forced the blood into the ventricle. So I now have an increased volume of blood in the ventricle. Again, I will then stretch the muscle fibers in the ventricle. The more I stretch them, again, the more forceful they will contract. The more forceful they contract, then I increase my stroke volume. If I increase the stroke volume, then I increase the amount of blood that is pumped out of the heart per beat. So now I'm increasing the volume of blood that is flowing. Right? On the other side of that is I can increase my end systolic volume by increasing the force of contraction, right? Which can also assist in that process. So by changing my diastolic volume and my systolic volume, I am able to increase my stroke volume. Okay? because if I decrease my end systolic volume, that means I've got less blood left in the heart after it contracts. So if I've got less blood in the heart, then I pump more out. So both of those are contributing to an increase in stroke volume. So stroke volume then, if we think about it, it increases by increasing the volume of blood coming back to the heart, which is our preload, and it increases, so that increases our end diastolic volume. And then if I decrease my end systolic volume by making the heart contract more forcefully, therefore there's less blood left in the heart after it contracts. So both of those are major factors, and we can change those with training, right? In the training methods I apply, I can have a big factor on increasing the preload on the heart. And if I continually do that, then I'll increase the function ability of the heart by increasing stroke volume. As the body only has a fixed volume of blood, then it must be continually returned to the heart for oxygenation. Venous return is the quantity of blood then that flows from the veins into the right atrium per unit of time, or 1 minute. So therefore our cardiac output and our venous return must equal each other. Right? We've only got X amount of blood. And we've also talked about the fact that the muscle contractions assist that venous return by squeezing the veins, and we looked at that briefly. And this creates a high pressure system. And again, all fluids move from high to low pressure systems, which then forces the blood to flow towards the heart. And we've also discussed the fact that within these veins there is valves that prevent the blood from flowing backwards. So it has a one-directional flow.